For today's video, we will answer a geometry challenge coming from one of our followers. And the question goes like this. Given the circle, draw a chord, and then from the center of the circle, draw a segment that divides this chord into 6 and 16 units. Now, the length of this segment must be equal to 8 units. Now, the question is, what is the area of this circle? Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so given this figure, our goal is to find the area of the circle. And to answer this question, I will use 3 different methods, and one of them must be the power of a point, or specifically, the chord-chord power theorem. Now, the second method is the Stewart theorem, and the third method is, of course, our favorite, the Pythagorean theorem. So now, let's start our solution using power of a point. Now, let's use the chord-chord power theorem, and this theorem, it says that if 2 chords intersect in a circle, then the products of the lengths of the chord segments are equal. So what we're going to do here is take a look at this segment, measures 8 units, and extend this, and let's make this a diameter. Now, it is a diameter because it passed through the center of our circle. Now, the length of this segment must be the radius of the circle, of course, and this small segment right over here must be equal to the radius minus 8 units, so r minus 8. Now, we have here r and 8, so if we add these two together, so the length of the segment must be equal to r plus 8. Now, we will use the concept of the chord-chord power theorem. So, if we do that, we have r plus 8 multiplied by r minus 8, here it is, must be equal to the product of 6 and 16. Now, from here, using the chord-chord power theorem, we can now solve for the value of r, and finally, we get the area of the circle. Now, let's do that. So, we have r plus 8 multiplied by r minus 8. This will give us r squared minus 64. Now, 6 multiplied by 16, this will give us 96. Now, let's add 64 on both sides. So, we have r squared must be equal to 96 plus 64, and 96 plus 64 is just 160. So, r squared is just 160. But take note that the area of the circle must be given by this formula, pi r squared. So, no need to find the value of r because we want r squared. And we know that r squared must be equal to 160. So, let's replace r squared with 160. Therefore, we can say that the area of the circle must be equal to 160 multiplied by pi square units. And that is the answer. So, using power of a point or the chord-chord power theorem, we get that the area of the circle must be equal to 160 times pi square units. Alright, now how about our second method, which is the Stewart theorem? So, let's do that. Now, given this figure, Stewart theorem tells us that if we multiply m times a times n plus b times a times d must be equal to b times m times b plus c times n times c. Now, this is the formula for the Stewart theorem, but it looks like this formula is very complicated. So, I have a trick here to memorize this formula very quick. So, here it is. A man and his dad put a bomb in the sink. So, this tells us that if we multiply m, a, and n plus d squared times a must be equal to b squared times m plus c squared times n. Now, to apply the Stewart theorem in our question, what we're going to do is, let's draw the radius of this circle, and from the center of the circle, let's draw the radius, and let's call this as r. Now, in this figure, let's base on the Stewart theorem. So we can say that the length of A in our figure must be equal to 6 plus 16 or simply equal to 22. Next, we know that B and C on our figure must be the radius, so we have B must be equal to C must be equal to R. Next, D must be equal to 8. Here it is. This is D. And N must be equal to 6. This is N. And M must be equal to 16. Now, using Stewart theorem, we can say, so we have 16, we have M multiplied by A multiplied by N, plus D squared multiplied by A must be equal to M multiplied by B squared plus N multiplied by C squared, or simply R squared. Now, from here, we can now finally solve for the value of R squared. So let's do that. 16 times 22 times 6, this will give us 2,112. Now, 8 squared is 64, multiplied by 22, this will give us 1,408. Now, 16r squared plus 6r squared, this will give us 22r squared. And if we add 2,112 plus 1,408, we get 3,520. Now, divide both sides by 22, and sure enough, 3,520 divided by 22, this will give us 160. Still, r squared must be equal to 160. So, we get that the area of the circle must be equal to 160 pi square units. Again, we get the same result using our second method, which is the Stewart theorem. Now, how do we apply Pythagorean theorem in this question? I don't see any right triangle. So, what we're going to do is to force this figure to have a right triangle. So, let's use the Pythagorean theorem to answer this question. Alright, so to do that, let's duplicate this segment measures 8 units like this. And so, by symmetry, this segment right over here must be also equal to 6. If this is 6, then this segment must be equal to 10. So, this 16 divides into 10 and 6, like this. Now, from here, we have an isosceles triangle. So, why not? Let's drop a perpendicular line like this, and let's call this as H. Now, by symmetry again, this segment right over here must be equal, so these are both equal to 10 divided by 2, or simply equal to 5. Now, given this right triangle, let's use the Pythagorean theorem to solve for the value of h, or simply h squared. So, we have h squared plus 5 squared must be equal to 8 squared. Now, 5 squared is 25, 8 squared must be equal to 64. Subtract 25 on both sides. So, h squared must be equal to 64 minus 25, and 64 minus 25 must be equal to 39. Now, I don't want to get the value of h, but I want to get this h squared. So, let's set aside this result. Now, let's focus on the segment that we want in this figure. So, let's drop this segment. We don't want this one. We don't want this one also. And this side. Now, from here, from the center of the circle, let's draw the radius of the circle in this point. Now, the total length must be equal, this side must be equal to 6 plus 5, or simply equal to 11, because 6 plus 5 must be equal to 11. Now, let's drop this segment. We don't need that. And here we go. We have a right triangle consisting of r, h, and 11. So, using Pythagorean theorem, we have r squared equals h squared plus 11 squared. And take a look, we have a value for h squared, which is 39. So, we can replace this h squared with 39. And 11 squared is 121, of course. Now, 39 plus 121, this will give us, of course, 160. So, r squared also equal to 160, this tells us that the area of this circle must be equal to 160 multiplied by pi square units. And that is the answer. So, using three methods, we can finally say that the area of the circle must be equal to 160 multiplied by pi square units. And as always, we are done.